Good morning, guys. It is April 24th, 2020. Welcome. You guys are doing an awesome job. Let's keep it up. Let's start with the riddle of the day. Remember, this is a 10% bonus, so everything that you turn into me, if you do it correctly and you show yourself and me that you know what you're doing, you're going to get 10 out of 10. You will get a 10% bonus. That means 11 out of 10 if you answer this riddle of the day by going into our chat and private messaging me your answer. Here it is. It's called Apple Harvest. Mrs. Jones was very proud of her apple tree. One autumn, after harvesting her apples, she called her 3 sons together. "Here are 150 apples," she said. "I want you to take them to the market tomorrow and sell them for me." She gave Paul 15 apples, Nick 50, and Ben 85. "Your job," added Mrs. Jones, "is to sell the apples in such a way that each of you brings home the same amount of money." How do they do it? Remember, post your solution in our algebra chat and make sure you private message me so everybody else does not see your answer. All right, so today we've been talking a lot about expressions, and we talked about factoring and expanding them and zero product property. Today we're going to talk a lot more about terminology and how we talk about these types of expressions. So our goal today is to identify the parts of an expression, which we're going to call a polynomial. By the end of the day, you're going to know what that is. And then we're going to find the sums and products of polynomials. So you're definitely going to need a notebook today or paper, and you're going to need to take some notes. So there are going to be different parts in the video where I'm just going to ask you to stop, pause the video, do the work, and then come back and check it. All right. First thing I want you to write down is this definition. So usually when we talk about an expression, we talk about each of the parts being a term. We're going to use a new word for that, a more sophisticated word. We're going to call that a monomial. So a monomial is the product of a number, which is the coefficient, and one or more variables raised to a non-negative integer power. So here's an example. 3x squared is a monomial. We could also consider it a term. It's a piece of an expression because it has a it has a coefficient, and it's being multiplied by one or more variables raised to a non-negative integer power. So this one is actually being multiplied by one variable, and it's raised to the second power. So it's an integer, and it's not negative. So this is a monomial. All these on the left are monomials. So if you look at them here, they're monomials. We might have called them term before. Notice they all have a coefficient. B doesn't have a coefficient, but that, if you don't see it, but the coefficient is 1. Okay? All right, so let's work through this. So I want you to just pause right now and make the chart. So pause right now, and then when you're done creating the chart, come back. All right. Did you make the chart? You better have made the chart. All right, here we go. So notice the first monomial, 3x squared. The coefficient is 3. The variable is x, and the degree is 2. So we briefly talked about degrees. That is going to be the number of the exponent. So negative 4a to the 5th power. Coefficient. Yes, that's going to be negative 4. The variable is going to be a, and the degree is going to be 5. This term, or this monomial, is the 5th degree monomial. What about the next one, b to the 3rd power? Coefficient. Think about it. That's right, the coefficient is 1. The variable is b, and the degree is 3. All right, so sometimes these first 3 monomials had just one variable, These next two here, notice they have two variables that are multiplied by the coefficient. So if we look at that, the first one's an example. 7x to the third, y to the fifth. The coefficient is 7. The variable is x and y. And the degree is 8. When you have more than one variable in the monomial, we add up the power. So we take the 3 from the x, 5 from the y, and that would be an 8th degree monomial. So I'm going to pause it right here and figure out what the coefficient, variable, and degree is for 5a to the third power b. All right, welcome back. What did you get? That is right. Coefficient 5. Variable is a and b. And the degree, that's right, it's 4. A to the third power, b to the first power. We add those together, it's 4. Take a look at the next one. Looks a little different, right? So in this one, we do not have a variable. So let's work through this. The coefficient is -1/2. The variable is none. There's no variable, so I'm just going to put a blank here. But there is a degree. This is called a 0-degree term. Okay? And think about it. If we did have a variable, let's say -1/2 x to the 0 power, I'm going to write this up here because I'm running out of space. -1/2 x to the 0 power is the same or is equivalent to -1/2 because x to the 0 power, anything to the 0 power is 1. So, long story short, anytime we have just the coefficient or the constant in this case, the degree is 0. So if we just have a constant, the degree is 0. Whoa, let's go back on that one. I don't know how that happened. All right, so here we go. All right, so now let's go to, erase this. I'm not sure how that happened there. Okay, so a monomial is a term, right? It's a piece of an expression. A polynomial is a monomial or a sum of two or more monomials. So a polynomial is really kind of what we would consider an expression. So 5ab to the fifth plus 6a squared. 3ab squared plus 5a squared. These are both separate polynomials. Now, this might help you if you really look at the word and break it down into a definition. So let's do this. Let's highlight something here. Monomial, we just talked about. Notice they have nomial in both. Nomial just means term, okay? So monomial, let's just look at the beginning part here. Monomial, and then we have poly. Poly means many, and for monomial, it means one, okay? So it's kind of like this guy we could think about, get back there. We could think about polynomial as being many terms. And then a monomial being one term. Okay, and so we're using new words like polynomial, monomial, but really we could relate those to words we already know. Expression. Expression's like a polynomial. It has many terms. And a monomial, which is one term, is equivalent to the word term. All right, let's move on. So, couple things here. The degree, let's talk about the degree of a polynomial. The degree of a polynomial is the greatest degree among all the monomials in the polynomial. So let's read this one. 13x to the fifth minus 9x to the third plus 4x squared plus x minus 13. Look at all the monomials in here, or terms. We have 1, we have 2, we have 3, we have 4, we have 5. Now we're going to look to the monomial with the highest degree. So we look at the variable with the highest exponent, and that one is 5, right? It's right in the beginning here. It's 5. Right up there is 5. So this guy has a degree of 5. Let's look at the next one. I want you to tell me what the degree is. 12y minus 4y squared plus 9. Pause it. Think about it. That one has a degree of... Yes. You should have said 2, because this 2 is the highest degree monomial in the set. So here we go. I'm going to write 2 here. Now, notice, and we're going to talk about this, and we've already talked about this, this one is not written in a way called normal form where we put the highest degree to the lowest. So if you see this written out, most of the time you're going to see it not negative 4y squared plus 12y plus 9. We go highest degree monomial to the lowest degree. Now, a polynomial or expression has a degree of 2. Look at the chart over here. It's called something. It's called a quadratic. So this here, anything with a degree of 2, a polynomial with a degree of 2, is called a quadratic. Two s plus 1, what does that have a degree of? That's right, it has a degree of 1. 2s is the monomial with the highest degree, it's 1. And that's called, and we already know this, it's called a linear. Like y equals 3x plus 2 or 3x plus 2, that's a linear, right? Remember, the degree is 1. Those are linear relationships. All right, final one here. 17 has a degree of, that's right. If it's just a constant, it has a degree of 0. So take a look at this. We talked about it. Now we could define it. I would write this down at this point. Normal form is a polynomial with its terms arranged from the highest degree to the lowest. So if you look at the two polynomials below, 5x plus 2x squared plus 3 and 2x squared plus 5x plus 3, they are equivalent. Which one is in normal form? That's right. This one is in normal form from the highest degree to the lowest degree. All right, one more thing we're going to do here, guys, is we're going to add and multiply polynomials. Now, you already know how to do this. We were calling them expressions before, but let's just work through this real quickly, just so I can refresh your mind. If we were to add these two polynomials, 5x squared plus 3x plus 7 and 10x minus 3, all we would do is this. 5x squared plus 3x plus 7 plus 10x minus 3. Okay, since there's nothing to distribute here, I could drop the parentheses and I could just combine like terms. 5x squared plus 3x plus 7 plus 10x minus 3. Let's highlight some like terms. Well, this guy's kind of by himself. These guys are like terms. All right? And then these guys are like terms. So if I combine them, I would have 5x squared plus 13x plus 4. All right, what if I were to multiply these two? So if I were to multiply these two, I would write it out a little differently. Let me see if I could highlight something here. Let me just see if I can make this a little bit smaller for us. Yes, look at that. Magic. All right. All right. So let me, now we got all these little splots all over. Let's get rid of these. Oh, we got rid of everything, didn't we? All right. That's all right. So now we are multiplying them. So when we multiply, that was a waste of time. 5x squared plus 3x plus 7 times 10x minus 3. How will we do that? That's right. We know how to do it. We're going to use our expansion boxes. So this is a 3-term polynomial, which is also called a trinomial. And the second polynomial is 2 terms, 10x minus 3. So I'm going to do a 3 by 2. All right, 3 by 2, expansion box, and I have 5x squared. I have 3x, I have 7, and then up the top, 10x minus 3. And now I don't even worry about like terms when I multiply, right? 10x times 5x squared. I'm just multiplying each of these areas, these boxes. That's 50x to the third. I'm adding exponents. Negative 3 times 5x squared, negative 15x squared. I'm going to keep on going. 10x times 3x, 30x squared. Negative 9x, 70x, minus 21. All right. You know what's interesting? When I do this, look at the like terms, how it's set up. Here's some like terms. Here's some like terms. These guys are like loners. They're by themselves. All right, let's see. No, that's not. Okay. So I can see my like terms here. If I combine them, remember I combine them, I add all that up, and I would have 50x to the third. I combine 30x squared minus 15x squared. That's positive or plus 15x squared. 70x minus 9x, that is 61x, plus 61x. Then I have minus 21. Notice I wrote this, and this is my final answer here when I'm multiplying. Please get in the habit of writing every polynomial in normal form from the highest degree to the lowest degree. All right, guys, so in your problem set today, you are going to be adding and multiplying polynomials. Remember to write all your answers in normal form. Remember, if you need, when you turn in your work, I'm going to be giving you feedback. If you are still not understanding that, I'm going to ask you, I'll give you some written feedback and ask you to send that back in. Please reach out, email, chat. I'm here for you. Have a good day, guys. Have a good weekend.